Hello, everyone. Welcome to the RADx Data Hub tour. My name is Leah Mason. I am a project and event coordinator for RENCI, the Renaissance Computing Institute. And RENCI is one of the RADx Data Hub partners, And today we're going to be presenting on our RADx Data Hub. And I'm happy to be here to moderate this webinar with you all today. A little bit of background to start us off. The National Institutes of Health launched RADx in 2020. RADx stands for the Rapid Acceleration of Diagnostics Initiative. It came from the urgent need to respond to the COVID-19 pandemic focused on diagnostic technologies. The RADx Data Hub is the infrastructure and the platform to house a number of studies associated with RADx. It's an aggregation of the study data, including diagnostic developments, diagnostic deployments, and COVID spread assessments. Today, we'll be focusing on synthetic data in the RADx Data Hub. We are recording this webinar, so we will be sharing that recording with registrants in about 2 days. Let's look at today's agenda. We have some amazing hosts with us today that will be sharing information. Leanne Samsa will give an overview of the need for RADx synthetic data. Asia Ahmed will go into detail regarding current capabilities and future plans for synthetic dataset generation. And Matthew Horridge will discuss metadata as it pertains to synthetic datasets. We will have a question and answer session, so please feel free to add those to the chat as we go, or you can wait towards the question and answer session. We'll be using the question and answer function in Zoom today, so please use that Q&A button to submit those questions. Our presenters will see those throughout, might answer throughout, or we'll make sure to answer those questions at the end. We're going to pass the mic off, and I'm going to hand it over to Leanne Samsa, and she can kick us off.
And actually, Leah, I'm going to take over. Leanne had a conflict and was not able to join at the moment. So my name is Robert Hubble. I'm the engagement lead, the outreach lead for the RADx Data Hub Partners. I'm also with RENCI, and I'll just I'll lead this part of the session and then turn it over to Asia. So we can go to the next slide. Thank you. In July, a couple years ago, the Data Hub had just entered the second year of its effort, and we were looking into what ultimately, when we were going to deliver the Data Hub and let people use the Data Hub, we wanted people to be able to access these data. And in that fourth quarter launch at the time, we were looking to see what we can allow people to play around with and learn how to manage and manipulate data within the Data Hub. And there was issues about the data itself from the actual studies. They are sometimes sensitive data, and there are certain access requirements. And so we thought about means to generate different kinds of data that people might be able to use to play around. Let's go to the next slide. Thanks. So little data had actually been entered into dbGaP and indexed in the Data Hub at the time. And there was also sort of no ground truth about the depth or the breadth of data that were expected. So we were trying, with this absence of data and absence of access, to try to figure out how to allow people to manipulate these data. There were different people that we wanted to allow. So database developers and metadata ontology builders. We wanted them to be able to understand how to use the data, and if they were going to be entering their own data, what sort of requirements there were. And there were all sorts of training and user requirement issues as well. Next slide. So the solution was to of course, keep these data shareable and accessible as always. All our data need to be, and figure out how to allow people to manipulate these data and understand the data elements. And we wanted to add some other features into this data set, this ultimately the synthetic data set that we're going to be talking about. We wanted the data to reflect real patterns that are out there in the world, in the RADx COVID world. So we wanted valid patterns and the breadth of data that are out there, including noise that might creep into the data. We also wanted to be able to implement some scientific trends or sort of hidden patterns that might be within the data that people who understood and were able to analyze appropriately would uncover. So Leanne, who led this effort, and others had these ideas of how to generate these synthetic data to satisfy some of these requirements. Next slide. So our initial product, and we'll talk more about this in the upcoming discussion, was to create a CSV file, a download file for the tier 1, which are the common data elements across all of the coordinating centers for RADx. So for those tier 1 data, we had common data elements, and we had these common data elements completed for multiple records. We wanted to make this shareable. This was iterative so that we could introduce, as I was describing, Easter eggs or hidden patterns within the data, as well as, of course, realistic values, and we could update this as necessary. We created multiple output files as if there were different studies. So we had a solution for study, synthetic study 1, another for synthetic study 2, etc. Next slide. And these data were used by developer teams to test the ingestion, to test the process that the actual researchers would be using to bring their data into the data hub. The synthetic data were used by the metadata folk. Matthew will be talking more about this, so that they could understand the metadata patterns and needs. And of course, for us on the engagement team to offer training and get feedback on the usage of the RADx Data Hub. Next slide. Just briefly, I want to mention, Asya is going to talk a little bit more about this, but there are other initiatives that are somewhat similar out there. There are others who are using generated data or using some kind of synthetic-like data. We're not alone in doing so. We think, sort of different in creating these synthetic data relatively realistically and expansively, comprehensively across all the tiers, the tier 1 and the tier 2 now data that we have, the tier 2 being common data elements within each of the data coordinating centers. So with that, I'm going to turn it over to Asya Ahmad, and she's going to go into a little more detail about the actual synthetic generation.
Thank you, Rob. Next slide, please. So I'm Asya Ahmed. I am currently pursuing my PhD at UNC Chapel Hill underneath Dr. Krishna Murphy. And today I'll be talking about the synthetic data generation. Next slide, please. So like Rob said, before pursuing our synthetic data generation, we went out and looked at the state of the art and what is currently out there for synthetic data. And the two studies we're going to focus on here is one that generates synthetic data using machine learning models. And what they do is they feed a real-world model or a real-world data set or actual data that they want the synthetic data to mimic into these models, and then they create the synthetic data that way. And then in study 2, they do a similar approach where they have the actual data set there that they use to create the synthetic data set. And so what we took out of these two studies and our research is that instead of using the actual data set, we can look for real-world COVID data trends in publications and novel trends that we've seen in COVID data and actually generate a synthetic data set based off of those trends. So in this creation, we hoped that we would create a shortcut for users to actually get to know the RADx Data Hub and play around with it. Please, next slide, please. So currently, the RADx synthetic data set evaluates the RADx Data Hub data at a tier 1 level, and this looks at the RADx common data elements. And then we also have current relationships found in this data and basic variables from the RADx Data Hub codebook available today with the help of Griffin Roop, an intern at RENC. It is successfully published under version 1 on GitHub. The link is displayed there if you'd like to play around with it. Next slide, please. So as for the structure and the process of creating the synthetic data, the user is going to be running a command line approach where they specify the template they'd like to be loaded, the relationships that are generated, and then the survey specific variables that they want generated in their synthetic data as well. And then the synthetic data is created using those relationships, the row count the user specified, some of the survey cases, and the output path. Today, we include 3 survey cases. Next slide, please. And so just to follow along at some of the current capabilities of our synthetic data generator, we integrate real-world data from PubMed, Nature articles, and things alike. And to improve our realism of the synthetic data that we generate multiple cases representing different research studies. We also integrate hidden relationships for analysts to uncover. So these relationships are not obvious to the user. They find them when they're playing around with the synthetic data generator, which is very similar to how real-world data is. And then we also have this user interface augmentation, which improves ease of use and distribution. In order to run this data set, you don't need much except for the command line. Next slide, please. So as for our current activities and future plans, we will continually improve structure, the process to generate increasingly realistic data sets for researcher exploration. We are now working on tier 2 and expanding our version right now. So stay tuned for that. And then we also want to enable specific adjustment implementations, especially in education, helping students identify patterns as well. And then we want to create an easy to use interface, allowing anyone to generate a customized data set. Next slide, please. Now I'll be passing the mic to Matthew Horge.
Thanks, Asia. Hi, everyone. I'm Matthew Horge, and I work in Mark Musen's lab at Stanford University. And today I'm going to talk about metadata in the context of synthetic data sets and the RADx Data Hub. So you've just seen the details of a synthetic data set, and in RADx, data sets are file-based. We have various kinds of data, for example, tabular data, image data, and sequence data, just to name a few. But no matter what kind of data, each data file has at least one metadata file associated with it. And I'm going to spend the next few minutes talking about the metadata that we provide in the RADx Data Hub. Next slide, please. So for a given data file, its metadata file contains semi-structured descriptions of the data file and its contents. And these kinds of metadata files are formatted in JSON LD, that's JSON for linking data. But because this metadata is pure JSON, it can be processed by any JSON processing library using a programming language of your choice. So for example, Python or Java. Metadata files contain details about when, where, and how the data file was created. They also contain ontology terms that provide semantic descriptions of data file contents. Next slide, please. Where possible, we use internationalized resource identifiers, or IRIs, and these are used to link out to more detailed descriptions and external semantic resources. So, for example, we use specifications such as ORCID, which stands for Open Researcher and Contributor ID. And here you can see the canonical ORCID example. So in this metadata file, you imagine we have this IRI, say, identifying the creator of the data. And this IRI, the one ending in 0097, and this identifies a researcher who generated the data. So if we resolve this IRI, we can see further details about the person this identifies. So for example, the name of this person is Josiah Carberry. And if we were to scroll further down, we could see details of the institution that this person works at and the publications. And we're looking at this on a website, but all of this information is programmatically retrievable. So it's all amenable to computational processing. Next slide, please. So let's quickly take a look at another example. And we also use ROR, which stands for the Research Organization Registry for identifying institutions that data sets are associated with. And here you see an IRI from a metadata file that identifies a research institution. And if we resolved this IRI, you can see that the identifier is for Stanford Medicine. We can also see more granular information about this organization. And again, this is programmatically accessible. Next slide, please. For tabular data files, we provide additional metadata in the form of data dictionaries, and these provide precise descriptions of the data contained in columns, the tables that are represented by the data files. So these descriptions include things like labels, data type information, pattern specifications, cardinality bounds, and ontology terms that provide semantic descriptions of column contents. Data dictionary metadata is serialized in comma-separated values, and that is CSV files. Like the JSON counterparts, data dictionaries are easily processed using off-the-shelf libraries for working with comma-separated value files. Next slide, please. Both types of metadata are fully described by open specifications published on the web. For both types of metadata, we provide rich detailed descriptions and documentation, and we publish these on GitHub, and you can see the links to the specifications there. So on the left-hand side of this slide, you see documentation for semi-structured JSON LD-based file metadata. And this is a manual that describes metadata fields and elements in text with examples of each field. And on the right-hand side of the slide, you can see the RADx Data Dictionary specification. And that describes the data dictionary fields in precise detail and specifies the syntax and semantics for each field. Next slide, please. For the JSON LD metadata file, we also provide a structured machine processable description of the specification in the form of a CEDA template. And CEDA stands for the Center for Expanded Data Access and Retrieval. This is the template shown in the CEDA Workbench, which is a graphical editor for metadata templates. You can view the RADx metadata CEDA template at this link here, and you can find out more about CEDA at metadatacenter.org. Next slide, please. So thinking about the synthetic data sets, the most relevant metadata for people working with a synthetic data file is likely to be the accompanying data dictionary. And as I said before, a data dictionary explains the meaning of columns in a data file. So let's take a look at some synthetic data. Here you can see a portion of a data file from the RADx synthetic data set. And you can see that by itself, the data looks indecipherable, and it's just columns of integers. To understand the meaning of the data, we need to take a look at the accompanying data dictionary. Next slide, please. So I've just got a snippet here of the data file and a snippet here of the data dictionary, a tiny portion of the data dictionary, just to give you a flavor. So this is the data file enlarged in the top that you saw on the previous slide. And if we take a look at the upper image then, and the column that's headed positive month COVID test 2, you can see some integers. In the lower image, you can see a small snippet of the data dictionary for this data file that specifies the meaning of these integers. So if you take a look at the row directly below the header, you can see the variable name positive month COVID test 2, and you can see a presentation label for this variable. So that is, what month did you first test positive for COVID? And then in the next column, there's a map of integer values to strings that specify the meanings of the possible values. There's other details that a data dictionary provides, quite a few details that I don't have time to go into, but if you end up using the synthetic metadata set or you access data in the RADx Data Hub, you have this data dictionary specification that explains all of these details. Next slide, please. So next steps, metadata. At the moment, the generation of data dictionaries for synthetic data is a manual process. Going forward, we intend to automate this so that a metadata file gets generated for each data file as part of the synthetic data generation process, and is formally linked then to that associated data file. Okay, at this point, I'd just like to give a shout out and say a huge thanks to Emily Kirstens from RADx Up. The synthetic data generation is based on RADx Up Tier 1 and Tier 2 data elements. And Emily kindly supplied us with a data dictionary file for the RADx Up Tier 2 data elements that we end up using portions of in this metadata set. Okay, over to Rob.
We are going to actually take a moment and get a demo from Asya. Are you ready to take over?
Yes, I'm ready.
Wonderful. I'll let you give the introduction of the demo that you'll be providing.
Okay, perfect. So I will be showing you all how to run version 1 that is currently in GitHub and open to you all today. So prior to running the terminal, I do want to look at this code book and kind of explain how the generator would look. So based on these RADx Data Hub concepts, global prompt, variable responses, and old values, if you just take a look at the first entry, we'll be looking for responses like reason unknown, not sent to Data Hub, and the list goes on. And so what our synthetic data generator will do is utilize this code book to generate the synthetic data and the responses that are actually allowed to be recorded through this codebook. So in order to run this version, we have users specify the generate.py, which does all the backend for you. And then we have a row count of how many variables you would want to see, and then the output path. So I traditionally just say my synthetic CDE CSV, and then as you run it, you will see that now the generated CDE file is available. And so looking at this file, we can see that there are multiple tests that were created. And then all of these responses were responses that were dependent on that RADx codebook I recently showed you. So they're valid responses. And so I also want to show you what we've actually been working on with Tier 2. So let's migrate the share to my desktop, actually.
Let me just step in for a minute just to, for those of you who are facile with Python and GitHub code, this is what Asya was showing you is generation. This is the version 1. So this is the tier 1 data, about 130 or so variables that are common across all of our studies in RADx. And what she's doing is she's generating a list of some number of rows of pretend synthetic records. Maybe it's people, maybe it depends on what the study is all about. And each record has all these values associated with them. and we'll talk a little bit more later about where those data come from. We're trying to make it as realistic as possible when we generate a record over here. If there's some relationship on a later variable, a later variable for a certain variable, then we try to form that relationship. So that's all taken into account into this generation. And what ASIA is showing now is our version 2, it includes the tier 2 data, there are many more records. We're still in process of putting in some of the details, but she's been working very hard on trying to make sure that all the logic that gets used to associate different CDEs are filled in.
Yeah, thank you, Rob. So just to continue on, one of the biggest differences with tier 2 is it's a lot bigger. And with the mass size, there is a lot more logic and reading and looking up relationships that we have to do. And then one of the ones that we are proud of accomplishing is this medicine logic that we have actually outreached and found publications to prove how users get medications and things like that. And so what we have done in tier 2 is actually bring this logic back over and allow the synthetic data generator to actually produce some medications for each test case that it runs. And so we're excited to finish this up and get it available to you all as soon as possible.
Yeah, those medicines come from the top 200 pharmaceutical prescriptions. We take into account systems, so we try not to trying to assign multiple medications for a given system, a given disease state, let's say, for a given patient, a given record, because that would not be very realistic. We generate some number of random medicines based on how many medications people generally take. So we have some of that logic in there. It's constantly being refined. The other item I want to mention is that we are going to put some kind of user interface in front of this for those who do not want to dive into the details, and we'll just be able to click a button, fill in some records that say, this is the kind of data that I want, this is what I want to generate, this is the information that I'm interested in, and then press a button and we'll generate data for them. We're not there yet. We're moving in that direction. We're happy for any help people want to provide, but that's where we're headed.
Yeah. So I will stop sharing, then we can move on to Q&A.
Okay, so so I will now facilitate a question and answer session with the panelists, and feel free to submit any additional questions that you have. We have a couple already through the Zoom Q&A button on your screen, and we'll address them. So the first question that we have is, what sources do you use for the data used to generate the synthetic data set? Astia, do you want to start that?
Yeah, so we use multiple sources online that are credible. One of the ones that we notoriously go back to is Nature articles. We take in mind the year of the publication. We also we utilize PubMed and things of that nature. As COVID data is constantly being published, we try our best to look for the most recent ones and find those trends available.
Mm-hmm. We're interested in census data. We're interested, like I suggested, in the top 200 medications. We're interested in being able to reference real data that are out there and real relationships that are out there between data, between variables, for instance, that we can support the realism of. Next question: how do I access the synthetic data? There's the GitHub element there. Asya, is there more to it?
Once you jump into that GitHub and pull it into your working space, just using the README and completing that command line prompt will get you the data. If you have any questions or concerns with running that, please let me know.
I'll make sure that the GitHub link is posted for everybody to see. We will also be sharing the this presentation after the session, after it's recorded, so that people can access. Let's see. Next question. Matthew, you can take this one. For the metadata, you mentioned the synthetic data mimics missing value codes. Can you tell us more about this?
Yeah. So when we started this work, it was observed that the minimally processed RADx Data Hub data, some of it contained blank values. And it was decided by NIH and the data partners that they wanted some explanation for these blank values. So part of the work was working on a set of codes, a vocabulary for missing values, to describe the reasons why values are missing from the data set. So the idea is you shouldn't have a completely blank value. And if you look in the actual data set, you can find these as codes that start with minus 9,000 and increase from there, decrease from there. And these actually correspond to blank values. So if you see these kind of codes in there, these what those are. And we've got a small ontology that describes the reasons for these hierarchy of reasons. That's further described in the data dictionary specification too.
Thank you. Asya, there was a question again posted about repeating how to access the current data set and what to do. Could you repeat?
Yeah, so if you follow that GitHub link and hover over to the README link, there is a quick start section where you can quickly install the requirements that you need through just a pip install, and then do a Python 3 generate row count 1000 and then output path to whatever you would like the output path of your synthetic generation code to be, and then that should work for you. But if not, please refer your questions back to us.
Yeah, we will post our emails or our means to access us so that you can, if you have any specific questions, please feel free to reach out. We have other questions. So the question, what kind of data are in the RADx Data Hub? The RADx, that's a very good question. So the RADx system was originally developed for, the RADx Data Hub was originally developed for the data that are coming out of quite a number of COVID-based studies that were initiated a few years ago by NIH to look into COVID and to have a central store for all these data. So there are different data coordinating centers. There's a center, for instance, focused on underserved populations. There's a center focused on advanced technology for the for studies of and capture of and assessment of COVID. There are a whole series of studies. I encourage people to look more into the RADx system, and so the whole initiative. And so this was a means to store all the information. We have a current version up running now for the Data Hub. We have another version coming up early in 2024 that is going to be a lot more flexible and have a lot more capability. We will then increase the ability for the synthetic data generation in that new system as well. So there's a series of studies in there. I wish I had the latest numbers. There's quite a few studies have published their data already, or at least metadata of their data to the Data Hub. There's a question I see now. What version of Python and what dependencies do I need to work with? Can I just download the data sets, or do I need to run the program? Asya, do you want to take that one?
So for the question of could you just download the data sets or do I need to run the program? Well, if there are data sets available to you on the GitHub for ease access. But if you'd like to actually generate your own, then you have to run the program and actually have that flexibility with how many rows you want and things like that. Then you have to go through and run the entire program. The version that we use is Python 3. The dependencies depend, it really depends on what you currently have, so it varies. But it's very flexible, and it doesn't seem like it needs much as long as you have Python 3 available on your computer.
Okay. And again, if people run into issues in running the Python code generating, please let us know. There's a question on how are the RADx common data elements determined? That was determined that was determined outside of this data hub group. It was determined by NIH and the DCCs to determine, mainly NIH, to determine what specific field needed to be captured, what information needed to be captured across all studies. So those were determined a few years ago. Those were given to all the DCCs and all their studies within to make sure that that everything was captured. So, and then the DCCs themselves generated, that's tier 1, and then tier 2 data were generated within the different coordinating centers for all the studies within their initiative, because some will capture demographic information. Others are more interested in assays, or they're more interested in measures of some kind, physiologic measures. So there were different, the technology was different. There were different kinds of data that were captured. So it made sense to have different tiers of common data elements for the different coordinating centers. Okay, Leah, I don't see any other questions, so I'm going to turn it back over to you to wrap up, and I encourage anybody to reach out with any questions and comments.
I did just see, right as you said that, 2 questions come in. We've got one in the Q&A, and then another I can read out loud, and then you can answer or you can hand off. What were the most challenging aspects of this work?
So you've been doing most of the hard coding, so I'm going to let you take that one.
Yeah, so one of the most challenging aspects would maybe be how many relationships there actually are. So you don't really pay attention to this when you have real data, but when you're looking at synthetic data, every variable depends on another, and there's kind of like attributes to every dependency as well. And that seemed to be the most challenging aspect of this work, just because everything that you change or everything that you want the code to do, it almost always changes something else. So as long as you have those dependencies and those relationships clearly identified, and we had, like Rob said earlier, this is a work in progress because of those relationships that are constantly ongoing and dependent on one another. So I think that may be the most challenging thing, just because it holds control of everything, and it really determines whether your synthetic data is up to par with real data or not. And that's something that we're constantly trying to do.
Thank you, Asia. Matthew, there's a question I'll give to you. Are you associating the enumeration value with a commonly accepted vocabulary term?
Yeah, it depends on the actual data elements. The data dictionary specification absolutely allows this. So it allows you to take choices field if they come from a restricted set of choices. And there's 3 components to each choice: the actual data value that you see in the data file, a label for the choice, and then you can also slot in an IRI for a term from an ontology. So we can do this for CDEs that already have these terms. associated with them. So CDEs from, say, the NIH CDE repository. There's terms associated with choices from vocabularies like LOINC and others, NCIT, and we can actually store these in the data dictionary files. And for tier 2 data, say, we've got DCCs looking at this too. So associating terms both with the CDE and with the choices that describe them in more detail and provide the semantics into each choice. Yeah.
Thank you. All right, we have so appreciated all of the questions and engagement. Would love to hear more from you. Earlier in the chat, we did put a link to a survey. We would love to hear feedback, as well as topics you'd be interested in hearing in future webinars. So again, that link to the survey is found already in the chat, so you can find that. Thank you, Susan, for adding that again. We'd like to also highlight 5 important resources that you can access from the RADx Data Hub website. That link has also been posted in the chat. One is the user guide. It's a step-by-step instruction for using the RADx Data Hub. If you're needing a hand, we provide support through the Data Hub help desk and our contact us form. Also, feel free to take a look at the commonly asked questions. There's a lot of great info there in the Q&A section. And you can also follow along with other upcoming events that you can register for to stay in the know of what's going on with the RADx Data Hub. Thank you all again for joining us. Please fill out the survey. And we look forward to seeing you in the future. We will be sharing this recording and the slides with those that have RSVP'd as participants in the next couple of days. All right, thank you to our panelists. Again, thank you all for joining us today.